So this is part 2 of our reaction mechanism lesson. We just finished talking about how you can use some information in a reaction mechanism to determine the rate law equation for a reaction. And the biggest piece of learning is that the rate determining step determines everything. So you get your concentrations, you get your exponents from your rate determining step. And so the other thing the rate determining step impacts is how fast the overall reaction is going to occur. If you want to increase the overall reaction rate, the rate determining step has to occur faster. If you increase any other steps, the reaction rate is not going to change, because it's the rate determining step that is slowing things down. If you can speed that up, then your overall reaction can happen quicker. So we're going to take a look at a reaction mechanism for not this reaction mechanism that we talked about in our first lesson, but the one before that, the one with the letters. So this one right here. So if we remind ourselves, it was our first elementary step that was our rate determining step. So we're going to graph a potential energy diagram for this reaction. And to do that, we're just going to start with our reactants, probably about right here. And we're going to come up to this point, and then, I don't want to come that far down. So I'm just going to fix that. And then our second step happens, and then our third step happens, and we get to our products. So this is elementary step 1. This is the activation energy for elementary step 2. And this is the potential energy change for elementary step 3. So the activation energy for elementary step 1, EA1, is quite a bit higher, you can tell by the graph, for from EA2 and from EA3. So, and that should make sense, because it's the reaction step that is slowing things down. Okay, so our rate determining step has the highest activation energy. Okay, so we're just going to draw another potential energy diagram for the rate determining, or for the reaction mechanism, for the other reaction mechanism. So I'm just going to quickly rewrite out that reaction mechanism. So we have a reaction mechanism there, and we can see that, or we know that it's elementary step 2, that's our rate determining step. So then elementary step 2 needs to have the highest activation energy. So if we graph that out, when we're doing real examples, remember that you actually write out what your reactants and your products are. And you are taking those from your actual reaction, so your overall reaction. And our first step is relatively quickly, occurs fast, so it does not have a high activation energy. And then our next step, though, occurs much slower, so it would have a higher activation energy. And then our third step occurs, and then we finish off with our products, and we write in our actual products here. So again, this is elementary step 1, and you should always be labeling these. I'm going to squeeze in the 2 up here and a 3 here. So then our EA1 is here. EA2 is here, and EA3 gets labeled here. Okay, so this is the end of our reaction mechanism lesson. I have some practice for you, which I will post in Google Classroom.